Hello guys, welcome to my YouTube channel. So today we will be solving educational code forces round 158 tip 2 problem D, yet another monster fight. Okay, pause the video, read the question, then we'll proceed. Cool. So the question says there is a character Vasya and he is fighting monster. Monsters are kind of standing in a straight line, so we can represent them as an array, or better to write something like this one: a1 a2 till an. Now what a Vasya can do, let's read about that. So Vasya is a magician, and to kill a monster, he can, throw some sort of spell or hit directly with some sort of energy beam. Let's consider something like that. Now he can choose any monster I. He can choose any monster I and hit it. Okay. Now once that monster is hit, so let's say if out of one, two, three, 4, 5. Let's say he chooses to hit this monster. Okay, so sorry. So let's he chooses to hit this monster first. So Vasa hit this monster. Now there is possibility that not possibility. The next monster he can hit should be the adjacent monster. Should be the adjacent monster of an already hit monster. So what I am trying to say is, if you read the question carefully, it says that the next monster you can hit will be a random monster such that that random monster should not be hit by the spell earlier, and it should be adjusted to one of the monster that was already hit. So see here, if Vasya has hit it this a3, then in the next turn he can either hit a2 or either hit a4. So let's say he hit a2. So this was the first hit, this was the second hit. Then he can choose a3 or a1. He can choose either of them. So let's say he choose a3, then this would be third monster. So for the fourth hit, he can either choose a1 or a5. So let's say he choose a4, okay, and sorry, a1, and then finally he choose this last. This is the fifth. So the catch over here is, or the question says that once the first monster he will hit will receive damage X. Okay, so he hit with a power of X, let's say. So this will receive power X, or will be damaged by power X. The next monster the next monster he hit, that is A2 in our case. So it will be hit by power X minus 1, and the next monster he hit, that is this third monster we hit, that is A4, will be damaged by power X minus 3. Then fourth monster is this one, so it will be damaged by power X minus 4. Sorry, here it will be X minus 2, and here it will be X minus 3. Similarly, this fifth monster we hit will be damaged by power X to the power X minus 4. But there are other possibilities, right? So let's say first of all he hit this one. Okay, so even after hitting this one, let's say instead of hitting this at the second, he hit it for the second time, and the third time he hit this one, and then again he hit this one, and then he hit this one. You can see carefully, or if you see, we are already always hitting a monster that was not already hit, and it adjacent to the already hitted monster, or the already sorry for my grammar, and it's always adjacent to the monster who has already been hit. So initially if we hit this a3, then the next he was hitting a4. So a4 was not hit till now, and it was adjacent to one already hit monster, so that is a3. So that's why we followed, and we can hit this a4. Similarly goes for 3, because this a3 is nearby a4, and a4 was hit, and this a3 was not hit, so we can choose a5, sorry, a5. And same goes for a2. For a2, this a3 was hit, so that means it adjacent monster is hit, and it has not been hit, so we can pick that. We could not pick that, like once we hit it, a3, a4, a5, and we can't pick this a1. Why? Because there is no adjacent monster to a1 which is hit. So we'll have to go with a2 and then come back to a1. So that was a question. And now what he wants, he he wants to kill all the monster in such a way that he has to you know uh, he should pick the minimum value of X. So we know that he can attack a monster with power x, and the next monster that will be chosen at random will be hit with power x minus 1. Similarly, then x minus 2, x minus 3, and x minus 4, and so on till all the monster can get hit. Okay, now here we chosen a3 as the first monster hit, but he might choose a1 as the first monster, or anyone, or let's say he chosen a2 as the first monster, and then we'll have many choices how we can go, on the left or right. If we'll see carefully, if this is our monster, these are our monsters. So if we select this one, right, if we select this one, let's say this one, then in the next turn we have two choices, either this or either this. Again, let's say if we select this one, then we have other two choices, but here those two choices are invalid, so we can't continue from here. The only choice we'll have is to continue from here, and to that too on the right side, not on the left side. Why? Because that left side is already hit, and from here we can go like this one. So if we'll see one thing, or yeah, or just to complete the question, what the question says is, now we have to return minimum x such that if that x is chosen and Vasya chooses any particular I, then it doesn't matter in which order you follow. So what does that mean? So let's say if Vasya chooses that this will be the first monster he hits. Okay, so he will hit it with power x. Now, as we said that there are two possibilities. Either he can go on hitting this monster next or this monster next. Okay, so what the question says is he can choose only this x, and it doesn't matter what order is followed next. So let's say if this was monster 1, 2, 3, 4, 5. So what are the possibilities? Either he can choose this 4 and then can choose 3, and after 3 he can choose either 2 or either 5. So let's say he go for 5, then after 5 he can either choose 2, and then finally he can choose 1. This is one of the possibility. Or if he chooses 4 first, then he might choose 5. Okay, then he might choose 3, then he might choose 2, and then he might to choose 1. So we if we'll see, we have different possibilities. So what the question says is he can only pick this 4, and it does not matter what in what order the remaining monsters are hit, that x should be able to kill all of them. That x should be able to kill all of them. Okay. Now, so Vasya can choose the first monster to be hit, and the rest order he cannot decide. Now the question says is what will be the minimum value of x such that he can kill all the monsters. Okay. So at first the question seems to be very complicated, but it's very easy. To better understand, let's go with this example. So 215,643. N is 6 over here. Now there, like, if we'll see, we have, if we'll select this 2, that Vasya selected this I is equals to 1, or better to say I equals to 0, as the first monster to hit. So he will have no choice but to hit it with power x, and the next element to be hit with x minus 1, and this next element should be hit with power x minus 2, 6 should be hit with x minus 3, 4 should be hit with x minus 4, and 3 should be greater than hit with x minus 5. Now we know that from the question it is mentioned that the monster will only be killed if if he has health point less than equals to x. Okay, so here you will see that's what it is written. A monster will only be killed if we will hit it with some value x greater than equal to its health point, or some power p greater than equal to health point. So in our scenario here, what does that mean? That means, like, if we want to kill this monster with power 2, then x should be greater than equal to 2. Here what can we say? That x minus 1 should be greater than equal to 1. Why? Because we know that from the question we will have only one chance, or that is only one x, and that should kill all the monster in this fashion, right? So from here we have, or it's, let me write neatly. So from the first, what we can write, x should be greater than equal to 2. From second index, what we can write, x minus 1 should be greater than equal to 1. From the third index, what we can write, x minus 2 should be greater than equal to 5. Similarly, what we can write, x minus 3 should be greater than equal to 6, and x minus 4 should be greater than equal to 4, and finally x minus 5 should be greater than equal to 3. So if we'll calculate the value of x, so here it is quite clear that it should be greater than equal to 2. From here it is also coming that x should be greater than equal to 2. From here it is coming that x should be greater than equal to 7. From here it is coming that x should be greater than equal to 9. From here it is coming that x should be greater than equal to 8, and here it is also coming that x should be greater than equal to 9. That means if we are hitting this index first, that is the first index with power x, so then as per the condition that we have to kill all the monsters in one go, then then that means we have to follow all this condition, and to follow all this condition we will have to select such an x that satisfies all this condition, and for that we can pick this solution, that is x should be greater than equal to 9, because if x is greater than equal to 9, then only it will be able to satisfy all the condition. Then what does that mean? That we are saying that x greater than equal to 9. What does that mean? That means that if we'll select, if we want to hit this monster first, then we'll have to select x is equals to 9. Why? Because if we'll select x is equal to 9, then at this place we'll have power x is equals to 8, at this place we'll have power x is equal to 7, x is equals to 6, x is equals to 5, or and here it will become 4. Though you will see that here it is becoming greater, but here it is the bottleneck. If we select any value lesser than this, then this 6 value, the upper 6 will go down, and that means we can't kill this monster. So that's why we needed to select this 9. Now we can always select any value greater than this x. So let's say if we would have simply selected something like 10 over here, so if you select simply 10 over here, then also all the condition will be satisfied. But in the question it is said that we have to select minimum x, that's why we are going for 9 over here. So so what do we saw? That if we select this 2 as the first index to kill, then we will have to select this 9, or the x value will be 9 for this corresponding first index. Now come again to this example only. So we have 215643, 215643. So now let's say instead of going for the first position first, we started with this position. Okay, so first we kill it with x. Now we have two possibilities. What? Either we can kill this one, or either we can kill this one. Okay, so as the question says, it doesn't matter in like you cannot decide the order you want to kill in. So what does that mean? That means we will be in the worst scenario, or we'll have to think of the worst scenario. So let's say if I kill this with x, then what can happen? I can either kill this one or this one. But if I'll see this one, what is the worst scenario? I can kill this, or what is the worst scenario I will be killing this monster in? So that can be, if I'll kill this first, again this first, again this first, and again this first, and then finally I kill this one. Listen carefully what I am saying. That if I am choosing to kill this monster first, then then I'll start with this one, right? I'll start with this monster. Now I have option to kill either this one first, then this one, and then again after that point, if I would have killed this one, then I will be again left with the opportunity to kill this one and kill this one. Else, if I choose this one, then again I will be left with opportunity to kill this one and this one, again this one and this one. If you'll see carefully, let's write it down to understand a bit more. So in the first scenario, we know that we are killing this monster first, or the index 1. This was 0th index. Okay, so if we are killing this monster 1, then we are using point x. Now our next monster can be this, either 5 or 2. If we are selecting 5, then in that scenario, for this two are, sorry, let's assume that we are hitting this monster at 2. So for this we will need just x minus 1 point, right? But but let's say instead of going this way, we selected this one, right? Then we killed this 5. Okay, so here it will be like x minus 1 point needed, and in the next after 5 we'll have two choice, right? That is to kill 2 or to kill 6. So let's say we killed 2. So if we'll follow this order, like first we kill this one, then we killed this one, then we are coming here, then in that scenario we will be left with x minus 2 points, right? If you'll analyze carefully, like instead of following this, what we could have done, we could have killed 1 first, then 5, and then again kill have 6, and then we can kill 2 and then remaining others. So what will in this scenario, we will be left with x minus 3 points. So if we'll, in the worst case, what we can do in the worst case, first of all, we will kill all the elements on the right. We will kill all the elements on the right, and then we will come for this. So in that scenario, we know that there are 4 elements on the right. There are 4 elements on the right, and we know that after itself, the point will be decreased by 1. Then again, after killing this, the point will again decrease by 1. So initially it was x, then here it will become x minus 2, then here it will become x minus 3, sorry, x minus 2, x minus 1, and then x minus 2, and then x minus 3, x minus 4, and finally it will become x minus 5. So we can say that in worst case, what is happening that for this 2, we have to make some equation something like this. If you want to kill this 2, we'll have to satisfy this equation, because in other cases it was always x minus 4 greater than equal to 2, or x minus 3 should be greater than equal to 2. So if we'll satisfy this condition, that is x minus 5 greater than equal to 2, then all this condition will be satisfied. Because what is this exactly saying? This is saying nothing but x should be greater than equal to 7. So if x is greater than equal to 7, then if here what will it will give, x greater than equal to 8, sorry, x greater than equal to 6. So if x is greater than equal to 7, then that will definitely be greater than 6. But if we'll choose x is equal to 6, then it won't be greater than equal to 7, right? So that's why in the worst case scenario, we can end up in such a situation that x minus 5 should be greater than equal to 2, and from that we can conclude that x should be greater than equal to 7. Now this is this is only for one index, right? What we are doing right now is, right now we have restricted it something like this, that we are killing this first, and we'll be killing this in the last. So we know that if we'll see carefully, that we can kill this element in the last, or or this element in the last. We cannot kill this element in the last. Listen carefully what I'm saying. We can always kill the side element, most side element, in the last, because we know that any monster you want to kill, its adjacent monster must be dead. Its adjacent monster must be dead, right? So we know that this two, there is no monster who is dead in the left. So that means I can only kill this two if its right monster is dead. Similarly, for this 3, here it will become more clear. So if for this 3 I want to kill this 3, that means I have to kill this 4. Then only I will be able to kill this 3. And to kill this 4, I'll have to kill this 6. Then only I will be able to kill 4. And to kill this 6, we must kill this 5. Then only we will be able to kill this 6. So what we realize, that this 3 will be killed at last, this 4 will be killed at second last, because we cannot jump something like this, that we kill this 4 directly. We cannot do that. Neither we can do the kill 3 directly. We'll have to go this way only. Why? Because to kill 3, we know that 4 must be killed, because there is no dead element right to 3. So 3 is not adjacent to any dead monster. That means we'll have to kill 4 if we want to kill 3. Then again, to kill 4, we know that 3 cannot be killed before 4. So to kill 4, 6 must be dead, and to kill 6, 5 must be dead. Now, so if we killed 1, then we have the option, either we can go kill 2 first and then 5, or we can simply go kill 5. But in the worst scenario, what we can do, first kill 2, then kill 5, so it will decrease a point further with respect to killing 5 directly. So what I'm trying to show you guys or give you an intuition of is the last element can be in the worst positions, last element can be in the worst positions. Then what does that mean, the last elements in the worst position? So let's say, let's consider some example as 1 7 4 8 8 9 1 2 3, and I consider, or better to write something like this, 4 and 3. Okay, so let's say if I choose this one, if I choose this one, that means what I can do, I can kill all these elements, all these elements, and then kill 4 in the last. That we can do, right? That what we realize. Or else what we can do, see, we can always kill it before that. I am saying the worst case scenario. Worst case scenario, see, we can always kill, at minimum of this much distance only. Like we kill this 8 first, then we kill this 8, then this 4, then this 7, and then this. So in that scenario, if we are using x point over here, we'll use x minus 1, x minus 2, x minus 3, and finally x minus 4. But in the worst case, what we can do, what we can do is, first of all, we kind of, yeah, so we killed this 8, then we kill this 9, then we kill this 1, then we kill this 2, then we kill this 3, and then we kill this 8, then we kill this one, then we kill this one. And so in the last, and how many elements we are killing? So this many, 3, and this 4, 7. Okay, so how much point here, it will be, point will be decreased 8 points, because it was already killed this one. So in total, the x point will be decreased by 8. And now again, forming the equation, x minus 4 should be greater than equal to 4, and x minus 8 should be greater than equal to 8. So from here, it was x greater than equal to 8, and here it is x greater than equal to 12. That means this is our best answer, or this is the possible answer, because if we'll select 8, it might happen that in the scenario we explained just right now, for this case, in that case it will fail. And we know that in the question it is clearly mentioned that we can pick monsters randomly, and here we are restricting the flow. But we know that in the worst case, what will happen, that this here we need 4 point, and that at max the expression would become x minus 8 should be greater than equal to 4. Okay, now, so if you'll analyze carefully, here, for this 7, what will be the worst case, nothing, but we'll have to kill all the elements on its right, and then we will kill it, right? Then we will kill it. Okay, so so now, now, for one index we can clearly see, like, how we can find the answer for one index. So let's say if we are selecting this one, what we'll do, we'll calculate the worst case indexes for all this one. Or better to continue with our example. So our example was, let me, 215 643. So 215 643. Now, let's say if we are selecting this 5, we know that in this worst case, for this worst case will be x minus how much, this 5 remaining elements. So here it will be x minus 5, and we know that this will be the same, or x minus 5 should here be as well. Why? Because we can, there is one possibility where we kill all these elements and then we kill this 3. So worst case for 3 will also be nothing but x minus 5. Similarly, here it will be x minus 4. Same goes for here, x minus 4. For this, it will be x minus 3. Okay. Okay. Do you think so? Like x minus 3? Yes, that is correct. Why? Because we'll kill this one. Then we have no choice but to kill this one, and then kill this one. And then in that scenario, we'll have x minus 3. And for this, we know that we are killing with x point. Now, we have worst case for on the indices, if we are killing this 5. So here you will see uh, x will come nothing but x should be greater than equal to 7. From here x should be greater than equal to 5. From here x should be greater than equal to 5. Here x should be greater than equal to 9. And here x should be greater than equal to 8. And here also x should be greater than equal to 8. So for this scenario, if we are killing 5 first, we need minimum x greater than equal to 9. So killing 5, we know that x should be greater than equal to 9, and our minimum possible answer is 9. So x can be 9. Now this was like we calculated all this in for this particular index. Now what we can do, we can simply run a nested loop. Okay, for each index, first we will select each index, then we calculate this condition for all the indices, and then out of all the indices. So what I am saying is, so like let's say first we choose this index 2, and then we calculated the minimum value of x, then again we selected this value 1, then again we calculate, let's say it was x1, then we calculated x2, then again what is it was 5, right? So for 5 we calculated x3, then 6, 4 and 3. So it was nothing but x4, x5 and x6. And what does this x1 represent? X1 represents nothing but, if we select the element 2 first, element 2 as in matlab 0th index element, okay, the value I am talking about. So if we're selecting this first element first, so we need at least x1 points. But if we select this one, we need x2 points. If we select this one, we need x3 points. And we know that Vasya is free to choose any index. He can start with any index. So what will be our answer? Our answer will be nothing but the minimum of all these values. So what we can say, our answer will be nothing but the minimum of x1, x2 till x6. So whatever the minimum value of this x is, our we can have that as our answer, because that will represent that. Let's say if x2 is our answer, that means that if he select index 2 as the first, okay, because sorry, index, yeah, index 1, if you considering 0 base. So if we are considering this element to produce our best answer or the minimum x, then he should start with this index and should have minimum x2 points. Then he will be able to kill all the monsters. Now till here I hope everything would be clear. I will just repeat what we realized. We realized that for any indexes, what we will have to calculate, the worst scenario that should be greater than equal to, in the worst case, what should be the value of, or the what should be the left hand expression, and that should be equal to the value of, let's say here it is b. So x minus y should be greater than equal to b. Okay, so for each index, first of all, what we'll do, we'll select some index. Okay, we select some index, and then for that we calculate the values or the possible values of x with respect to all the other indices, okay, considering their worst case. Okay, now we'll do this for all the indices. So like for one index we calculate the what is the maximum x that we needed, and for all the indices we'll pick the minimum of all those x's considered in one individual cases. Now, but that will take o of n square. And if we'll see the question, that will give TLA. So now what we'll have to do is, we have to we have to you know calculate the worst cases. Like ideally whenever you have kind of nested loop, it's probably what you'll see here also. In here also, what we are doing is, we are selecting one index. So let's say here we have all elements, so we are selecting all the indices, and then we are calculating the worst case for this one, then worst case for this one, then was that is selected, so it will be x. Worst case for this one, worst case for this one, and worst case for this one. Okay, so can we, and now see in the next iteration what we'll do, instead of starting from here, we'll start from here, this next index. So can we use our previous result? Can we use our previous result? Because if we can do so, we can remove this loop, and overall our solution will become OM. You will see how it will become. So let's say what I am saying now. So continuing with our previous example only, we have 215643. Okay, so if we have 215643, so let's say if I choose this 5, right? In this scenario, the worst case value of x, this 2 will be nothing but x minus how much? We will kill all these elements, right? We'll kill all these elements, and that will become x minus 5. Okay, now, now if we move from this this one this one to this index. Okay, if we move from this one to this index, then what will be our value for this 2? Then what will be our value for this 2? If we are choosing this one, then we can kill this one, then we 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 kill this one. In all the cases, it will be nothing but x minus 5 only. So if we'll choose this one, it will still be x minus 5. Okay, so so what you realize over here is we have some kind of connection in some kind of connection for one particular index, or the worst case for one particular index. So so and the second thing what you will realize is, if we select this two, right, if we select this two, and here if for this pipe if our x was 4, right, then to satisfy the same condition, or better, see here it was x minus 5 greater than 2, right. So if in this scenario we'll have to pick 7 over here, right, and we know that for this 6 we still have the same condition, the condition does not get changed. That means now for this x, what will happen, we I still have to satisfy this condition, and from here it will feel like that x should be equal to 7, right. So from here what we realize that x should be greater than equal to 7. So similarly, for if we'll choose this also, right, if we'll choose this also, then also this will be nothing but the same condition. So what we can see from here is, for each index we have this fixed value or the fixed constraint that we need to satisfy. So for this we know that it is nothing but x minus 5, and that will be same but this x minus 5. And for this it will be nothing but x minus 4. Why? Because we know that this 2 will always be killed, this after this 1. So what we can say is, similarly, like i for any index I, what value we can have is nothing but x minus c. The remaining elements is nothing but n minus 2, because we have selected some element as x, right. So, and all the elements in its left must be killed before it. So how many elements will be there in the left? That will be nothing but I, and this should be satisfying the value of a of I. Okay, so this should be satisfying the value with a of I. So from here what we can write, that for any particular index, this x should be greater than equal to a of I plus n minus 2 minus I. Now see, fourth, and what is this a of I? What is this a of I? A of I is nothing but the value of that particular index. So for all this index, what we can do is we can calculate this value, and out of all those x, whatever the x whatever the x will be minimum, we can have that as our answer. Okay, so I hope that would be clear to you now. So you realize that for one index, the worst case is always the same. But you'll soon realize that the worst case does not matter. Like, we know that for this two, worst case is x minus 5, and for this x minus 4. But the worst case for all the indexes won't come true at the same time. Remember what I am saying, or understand what I'm trying to say. So we have this number, right, 215643. We know that the worst case for this 2 is nothing but x minus 5, and the worst case for 3 is also nothing but x minus 5. But but this x minus 5, the worst case for 2 and 3 cannot occur simultaneously. That is, if we are choosing this 2 in the last, that means for this the worst case would be something like this: x minus 4 should be greater than equal to 3. But if we are choosing 3 first, sorry, 3 in the last, then this, for this it should be x minus 4. So now the our theory saying that all the like for one index the worst case would be in will be the same for all the indices won't get validated. But we know that somehow it will come into the picture. So how will it come into the picture? Now let's understand that. That was very important to clarify why we are not taking all the worst cases, or simply collecting all the worst cases for all the indexes, because we know that two worst cases will not occur simultaneously. So there will always be if and but. Okay, if we are taking this one or if we are taking this one. So but there is one thing. So let's say if I have this numbers, right? So we know that if this 4x, for this 5, for this 5, if we are at this 5, right? And we know that to satisfy this one, or to satisfy its left side, we need how much point here? If we would have selected x here, it would have become something x minus 1, x minus 2, and similarly for right now we are just focused on its left side. So if we are focused on the left side, we can see that to satisfy we need, let's say, how many points over here? So if we would have considered this 5 over here, this it will become 4 over here, and it will become 3 over here. Okay. Now we know that if we are moving forward, that means all the indices, our effect will decrease by 1. That is, if we had x equals to 5 over here, and we still select x is equals to 5 over here, that means all in our left, the indices value, or the influence of this x would be decreased by 1. So here it was, the influence was 5, now it will become 4, here it was 4, it will become 3, here it was 3, it will become 2. Now can we use this information? Yes, we can definitely use this information. How we are using this information? So if we'll realize one thing, what we are doing what we are doing to kill all the monsters in the left, we need nothing. But if we are at this position and we want to kill all the monsters in the left, then we have only one possible way, that if we have selected this monster, then we'll kill this monster, then we'll kill this monster, then we'll kill this monster. Or what we can say, that to kill this monster, we need how many points? This actual points plus k is nothing but the distance from here. So what we can say, that if we are at k is equals to 1, that means that is here, k equals to 2 is here, k equals to 3 is here. So now just consider one thing. So initially there was 5 over here, and there was 1 over here, and we are shifting to this index. So or from this index to the next index, or from we are coming from this 1 to this 6, and then we moving forward like this way. So initially what we would have done, we would have started from our first 5, and then we would have went to 1, then we would have went to this one. So what we can say, that for this 5 for this 5 we need, let's say, x points. We need x point. Then when we'll go at this point, then for the previous, what we can do, we know that all the points changes something like this, that the last one becomes something like this: a of I plus k, then second, or a of 0, let's start something like this, and then it will become a of 1 plus k minus 1, then again it will become a of 2 plus k minus 2, something like that. And when we will shift 1 point, then this entire equation shift by 1, and it will become something like this, that whatever the x we have selected, for the same x, this k value should be incremented by 1, right? Or the power will be decremented by 1. Why? Because this the second last value, that, or the value for this scenario, whatever the index we have selected, we have moved one index further. So initially here, whatever we have k, that is k was nothing but 0, or okay, k was 0, then it was 1, then it was 2. Now it already had shifted one place this side. So here it had become -1, it had become 0, or not -1, it has become whatever x we have selected, it was already subtracted from 1. Okay, and then subtracted from x minus 2, or you get the point, right? So what we need somehow carry forward this one. So if I think it would be better to explain with the code. So let's say what we'll do, for any index I we'll store what will be the worst case if you want to kill all in the left, and what is the in the right array. We'll store what will be the worst case if we want to kill all the elements in the right. Now we know that if we want to kill the first element, or let's say, okay, so here we have some element, and here we have some element, and here we have some element. We know that if we are at this, let's start from here. If we are at this place, then to kill all the elements, to kill all the monsters in the left, we know we need how much point, whatever the value of this monster health point, plus one. Why? Because we cast a spell of x, and that spell will decrease by 1. So the x minus 1 should be greater than equal to this monster health point. Now when we'll shift to this one, we will see what we will see. Before shifting we will check. See, we know that we'll keep track of the maximum value on our left side, and maximum value will be not just a of I, but the maximum value will be cumulative of mx plus k. K will be nothing but the distance. and and initially, see what we have done. We have started from the last, or the first, sorry, the first index, considering that the zeroth index, considering the zeroth index is on the left, and to kill that we need 1 points, and in the worst case we'll have to kill all on the right. That's what we have already discussed here as well, right? Now if we kill that we can have this many points required, right? Now if we are moving from this particular index to this index, right? If we are moving from this particular index to that index, what does that mean? That means that if we select, or if we kill this element first, then how much point it will take to kill all the elements on the left. So what will happen? The earlier mx was there, mx plus k, and now there can be a scenario. What scenario I'm talking about? Let's say it was 5 and it was 100. Okay, so though for here it will k will be 1 and k will be 2, and the next time we will be selecting this index, right? So what is k is equals to 1? K was nothing but the distance. So here it was, for here it should be x minus 1 greater than equal to 100, and x minus 2 greater than equal to 5. We know that this 100 is greater than this x minus 2 greater than equal to 5. So that's what we are doing. We know that this second condition will always satisfy this first condition. That's why what we are doing, we are selecting this mx element, and if that is less than equal to a of I, we are just assigning it. Okay, and selecting the k equals to 1. Why? Because our new pivot point will become this one. So from here we have just 1 point, and if we move one forward, then we'll update the k by 2, and we'll keep on mx. If you'll see, mx is keeping on updated. Okay, we are keeping updating the mx. Now same thing goes for the right. Now what at the end what we'll have the left right value for all the indices. That what will be the value. And yes, there is one more thing, that this right minus minus, initially it will be n minus 2. Why? Because if we'll see, if we sell, no, for this worst case we'll be killing all these elements, but for this will be nothing but we can kill only this one element, and then we'll have to kill this one. For this one we'll have to kill all these elements, and then we can kill this one. Similarly, we are selecting that we will be killing the left at the last. We can also kill this 3 at the last. So in that scenario also we will store all the result in this right vector, and finally we can return the maximum of left, right, and whatever the value itself has. Okay, and finally we'll return it. Let's try submitting this solution. Okay, I hope everything would be clear to you, but if you guys have any doubt, let me know in the comment section. Let's try submitting the solution. Okay, so see, this is an accepted solution, but if you guys have any doubt, feel free to ask in the comment section. Thank you guys.